Hey everyone, this is Martin. This is a dev log update for the OpenGL C++ FPS Game Engine tutorial that I'm going through, which is one that I'm following on Udemy, and basically this is just sharing as I'm going along, joining the adventure, and as I'm building and sharing, I'm kind of learning at the same time. So I'll show you first what's happened since last time. Actually, I can't remember what the last video was, but this is what we've got at the moment. So we've got a little bit more of an FPS looking prototype engine now, so we've got WASD controls. I think that was also in the last video. You can see on this Susan model here, we've got specular reflection, so you can see sort of above the eyebrows there, as I move around, the specular reflection changes based on the camera angle. You can see a little bit more maybe from the side of the head there. You see that specular white highlight, and as I move, it disappears. You may have seen it when the application started there, but there's some small animation that isn't on repeat. So what I'll do is I'll just turn that off and set that to looping. By default is true, and you can see what's happening. And what I'll do is I'll look through some of the scripts that I've followed along and copied. So there we go. So you can see there, it's just a looping shooting animation. So early stuff, early days, still a lot to do, but you can see it's coming together. It's coming together, which is nice. So that's good. I'll just undo that there. So the main things that I've done as I'm following along this course, and again, just to explain in the last video, to reiterate, I can't show all of the code. This isn't a tutorial. It's just me following this course on Udemy, sharing as I go, and as I'm talking through these and looking at the scripts that or the code that I've written, I'm learning and remembering, and it's helping sort of refresh and keep it up to date in my head, because just typing along and copying sometimes, you're not learning as much. So, but these are the last three things that I've done. So full GLTF loading, gun and specular lighting, as you just saw there, and animations as well. Those are the three things, and these are quite chunky classes as well, quite chunky courses, I should say. What I'll probably do is I'll just go through a couple of these classes here and just see and try and follow the trail of what happened. So, kind of first up in game CPP, which is down here within the source file. This is like the actual game as opposed to the engine source up here. We're first loading the gun class here, the gun model here. So again, scene GLTF, and it's full parsing now, so that's the full scene. So multiple objects are created, multiple nodes within this GLTF model, which correlate to one game object each within the scene. And then at the bottom as well, you can probably tell there, like, animation is getting parsed as well. So load GLTF is where a lot of the chunky work happens, and this is all based off of the assets directory here. So you see you can got models, assets is sort of the root of where this all begins. And if I go into here, if I just back up a little bit, models, stem gun machine, so it's this one here. So we've now got resource loading as well. So this one was the monkey head, that Susan thing, and then as I mentioned, this is a full GLTF scene, and then scene.bin is the binary data. GLTF describes how it is actually put together, and I think this is just it's just a JSON file. There's quite a lot of data in there. Wow, whoa. This describes a lot of it. I've not read through this, but in combination, these two in combination work to create, to have all of the scene data. Setting the parent to the camera as well, so that's the other thing. Like, this is again kind of, I'm trying to tie this in my own brain as close as I can to Unity, just because that's where I have most of my experience. Is okay, set parent, that's something that we do in Unity. I get that, set position, set scale, of course. Get component, okay, this makes sense as well. This is something that we do in Unity. Find child by name, again, something that we do in Unity. So in this case, what we're doing here is if when we've parsed this scene GLTF asset, this model, does it have any animations on it? That's all automatic. If it's got animations on it, if that's what the GLTF file has told us, then parse the animations. And then what we're trying to do here is just trying to find the child by name. So the creator of the video knows that, okay, bullet 33 is one that we want to turn off, and then also this boom 35. What I'll do is just to show you as well, like if I do that and then just undo that as well, this should then show the bullet and that sort of the boom animation. When it's just a basic cube and it should repeat, but you can see how things have been turned on and off there. So again, this is very, very obviously super basic in terms of like the visuals, but it's the foundations of how an engine is put together, and I'm learning this and all the bits as I go. You know, this is much more nitty-gritty engine level stuff, which is exactly what I want. Let's just back this up here. Okay, so that's sort of like what you might do in Unity there. You load a model, you set its position scale, then you turn things on and off, and you set the animations to play and loop and so on and so forth. The load GLTF is a big chunky one. So if I go to here, this is within the game GameObject.cpp, which is a part of the engine over here within the scene. So this is core engine classes which are exposed to the client side code down here. So you can create, you know, a game.cpp which spawns things as test object that derives from GameObject.cpp. But very, very briefly, I don't know all of this, and I don't want to go into too much depth and just rattle off, you know, line by line, and it's not going to be very interesting. But it gets the asset file, you know, the contents of it. And again, I am just rereading this as I go and just trying to understand here. Okay, so get all of the GLTF data into buffers. So results, so read everything basically from that GLTF file. I think the GLTF file itself is referring to this one here, not the bin file, as far as I'm aware. I could be wrong. Again, I need to know more of this and read as I go, and learn more as I go. But anyway, this is what I put together as well. A little bit of comments of how this kind of works when we're doing the parsing. So the GLTF node, so within the GLTF scene file here, it can contain multiple nodes, and they basically map to a game object. So just think of a node as a game object. Those nodes can have meshes, you know, so the Suzanne monkey head mesh. Primitive is what in GLTF terminology is a drawable object, as far as I'm aware. And so what we're doing is we're separating that out. Okay, the primitive contains geometry and a material, and then we're mapping those to a mesh component that lives on the game object itself. So this could be multiple nodes within the GLTF file, and I think somewhere down below we create like a parent one as well. But I guess the main point is that everything that is GLTF nodes maps to a game object. So like in Unity, when you import an FBX file, you could have, you know, a character like holder, and then under that you would have like the head, and then the body, and then the legs and the feet and so forth, or whatever model it might be. And that's all extracted in Unity, and it knows how to make those separate game objects and add mesh components, animation components, you know, that's kind of legacy stuff, but materials and so forth. So that's kind of pretty much what we're doing here at a simple level, but it's handling meshes and it's handling animations now, which is great. So parse all the top level nodes and child nodes recursively. So this is where, you know, a lot of the magic is as well. So if we parse a GLTF node, so if I go to the definition in there, you see we're getting the node and the parent game object that we want to attach it to as well, because it could be a child of something as well. Create a game object for the node. So there you go. This is what I was saying on that chart before, is for the object that we're about to parse, create an object and then make that object a part of the scene, and then add all of the animation bits. I think that might be in a separate class, not a separate class, but a separate function somewhere. Probably needs to be extracted out of game objects at some point. But yeah, we handle the transformation first of where this object lives in the world. If it has a matrix, yeah, if we're translating via a matrix. If not, we're just parsing the vec3s, I think, or again, this is something I'm not 100% sure of how it's, working. Like, if there's a translation node, then set the position based on that translation node. This just looks like a vec3, and then we've got a quaternion there. Handle any meshes. So this is, again, parsing it. If the GLTF node does have a mesh, then for each of those primitives, lambda to read vertex attribute data from GLTF accesses into floats. Yeah, so this is more where the parsing of that data is. And again, I'm not 100% sure of how this works exactly. These CGLTF accessors, I'm not sure exactly how these work, but I think what they're doing is they're grabbing it from this scene binary data here and then pulling that out and parsing it from the binary data. Again, I've not gone into too much depth of how each of these work because I do have to get through it somehow. Vertex layout, handling how they're meant to be. Oh, how can I put this now? Vertex layout. I don't know if we put that in. Don't know if that was mentioned in the last video or not. Let me skim down and see if I can kind of figure it out. Vertex on, for example, RGB component. Yeah. So, yeah, pass it. Does it have position, color? Does the vertex data have position, color, UV, that kind of stuff? So for for example, if it's type position, it's saying, hey, then pull that data out, and then element.index, yeah, is the position index, and this maps to the shader as well. We've got just a single shader within the project, but what we're doing is saying, yeah, this is the position data, here's the color, UV, normals, etc. Yeah, of course we've got normals because we've also got specular as well. So that's all the vertex layout is. I'm a little bit rough on this in my mind of how this works exactly, but for example, you've got RGB in vertex data, you've got UV, you've got normals, and so on, and then mapping that to the different position indexes within the shader as well. So if I go to the shader here and look at vertex, what we've got is there. So location, 0, 1, 2, 3, position, color, UV, normal. That's what. Where did it go? Just here. Yeah. So there you go. Position index, color. What happens is in the. Oh boy, where is it now? There's a class in here which maps them. Actually sets the values on the shader. Oh, I've forgotten where it is now. It might be render. Not render queue, not mesh. It might be graphics. Graphics API, maybe. Okay, default shader program. So yeah, create the vertex buffer, set color, bind shader for bind material. I forget on where it is. It might be shader program. Let's see. I'm sorry. Let's say this video is pure just devlog. Me just digging through and taking a look, and not really. It's not a tutorial by any means. So, yeah, but I do hope you're finding some of this interesting or useful. There you go. So get uniform location in the shader of the particular thing that we want to set. Set texture. Where is it now? Set shader program. But anyway, my point is that once we've extracted that vertex data, then it gets mapped to the shader when we're doing the draw call. Is what I wanted to say. So let's keep going anyway, and again, I'm going to kind of skim through this, going through all the vertices. Then we create a mesh component here. I think that is the case. So creating a mesh, and then we create a mesh component, I believe. Set shader program, graphics API, get default. Yeah. Oh yeah, handle materials. So yeah, passing the materials as well from the GLTF file. So again, everything's getting extracted out of it. There's a lot of stuff here. Handle specular and glossiness as well, and there you go, adding the component, the mesh component. So again, this is kind of Unity, how I'm relating it to Unity in my head, just again because it makes a little bit more sense for me that way, and nicely transitions me into thinking more on the engine side. Material component, mesh component, updating the mesh. Yeah, we looked at this last time, I believe. So final position and submitting it to the render queue. Yeah, okay. And that all gets parsed automatically, and the mesh component gets added to the game object. and there it does it recursively, so all the way down. So if we've got multiple levels of child nodes, child game objects, and that's where that all gets handled. Now let me go back a touch. Where was I before? So load GLTF model, set the parent, set position, set scale. There was a lot animation component. So if we get component, if an animation component was created. So this is the other part I kind of wanted to talk about a little. If I can find where it was before, because passing the GLTF node here, load GLTF. There was a part on animation as well, and I may have skimmed over that actually, or it may have been the same thing that I was looking at. Animation. There we go. Yeah, there we go. So animation. It was parse animations. Yeah, animation clip. That's the other one I wanted to talk about as well. I'll open that separately and I'll go to it in a moment, because this is what kind of made sense to me as well, which was it was like a little bit of a light bulb aha moment in terms of just my understanding of how things work under the engine hood. But here, yeah, so we're passing animations count. You see that we can read in that the GLTF JSON file here and saying, hey, there are animations in here. If there are, then let's start to extract them. Get or create track. So I guess let me go to the animation first, then I can kind of explain what that means, and then I'll come back to the game object. So if I just pull this up here, so this is what the animation is basically. So keyframes for vector 3, keyframe quaternion. So this would handle position and scale, and this one would handle rotation. And then for each track, we have position, rotation, scales as like a list or a vector of those. So I kind of think of tracks as like what you'd actually see within, say, the old animation editor, is it? The animation component editor. It's been so long since I did that in Unity, but you have like, you know, one track that handles X, and then you have one track that handles Y, and then you have one track that handles scale and rotation, and for each game object. So that's kind of, in my mind, how I've been thinking of it. And then for an animation animation clip, sorry, it has a list of actual transformation tracks, transform tracks. So an animation clip is kind of, again, relating it to Engine Land, and this is probably same for Godot or Unreal, but kind of legacy animation components that you'd add to a game object, and you'd then have a clip field. I know the new mechanism system is slightly different. It's a little bit more complex with its blend tree stuff and its layers and so forth, but I'm just thinking at a basic kind of like old level legacy, where it was an animation component and a clip, if I remember correctly. That's what this kind of relates to. This is similar to what it is right here. You got the list of tracks, and then, you know, those tracks contain all of the list of positions, rotations, and scales. Binding as well is which game object does it relate to. So this was kind of another aha moment, or I guess a little bit more understanding briefly. You know, neurons were kind of firing a little bit and making connections. You've got a list of game objects that each of these tracks relates to. So is the position of the finger moving? Is the position of the rotation of the wrist moving? You know, which game object is that? I don't know. Is it game object finger 1, finger 2? Is it shoulder left, shoulder right? So this is what this object binding does. Is it connects the name of the game object to the animation. I'm 95% sure on that. So yeah. So that's what this whole animation component is. And am I in .h? Oh, this is animation.h down here. Yeah, this is just like another component down here, but the structs have been declared up here, and I don't know why it's got unsaved changes in there. Why is it doing that? I'm looking at this asterisk up here. Why is it saying unsaved? It doesn't matter anyway. I mean, I've got this all backed up through source control. So that's the animation component anyway. That made a lot of sense to me. Now, I guess it's a little different for me coming from a very visual editor land, like probably most of you are, where you've got a nice scene graph with game objects and components on those, and you can move around the world and drag cubes in, and you can see what's on each object real easy. Well, that's the difference. I guess one of the differences here in terms of workflow is it's harder to see what's actually got parsed and added to an object. So that might be something down the line where I add some tooling around being able to see things. So using things like IMGUI to display a list of game objects. Maybe that's future stuff, and just as I'm building, if I find it useful or interesting. So going back here anyway, this animation clip, and we're inside of the load GLTF function here. Get or create track. So this is a lambda that we're passing in somewhere else down below. Now iterate animation channels. I don't know what animation channel means exactly. As I was following along and typing this out, I wasn't 100% sure. But we're getting all of the times from the animation track, because obviously you've got, it's keyframes, it's animations. So at 1.2 seconds, what is the data? At 3.8 seconds, what is the data? Is it vector of 3? Is it a Cottonian? Whatever. Creating the track here as well. Check what kind of values have a sample output target base. There you go. So this is where we're using a switch statement to say, is it a translation? And again, we've got this little helper here to say yes, based on the data that's in this GLTF file, is it a translation? Then we are making we're reading the output of a vector 3, and then we're adding that. There you go. So this was kind of it as well. We're adding to the track, as in the animation track, which is you can have a list of tracks within an animation clip. Tracks themselves are lists of vector 3 Cottonians for position, scale, and rotation. So we're extracting that data and then we're adding it to the positions. Same for rotation as well. We're adding it to rotations, and same for scale as well. And then there we go. Clip, the duration, which is being extracted out as well. Clips.pushback. So we're moving the. All right. So the list of clips that we've got within the animation, I think that's what that is. I could be wrong. Clips, pushback, clip. Where's clip? And you can see how I'm kind of learning as I'm going here. So this is animation clip, right? Clips. Yeah. Okay. So I've got a bunch of animation clips, and then we're pushing that to the back. So it's basically a list of animation clips. And then creating the animation component again. So full parsing of this GLTF file, as I mentioned at the beginning. If we've got clips, then yes, we want to make an animation component, and we want to add that component. So this is more Unity, kind of how I'm kind of tying that in my mind to Unity land. So adding a component. So we've got a list of components that actually lives on the game object there. So there you go, list of components, or children as well. Makes a lot of sense. You've got a scene graph, and how do you render things based on a scene graph? And if you've got a child object which has got its local offset, then you need to render that based on not only its local offset but the parent's offset as well. If that's got also got parents, or if it's not got a parent, it's just based on the world location. So, but this, there you go. Find child by name was the other one as well, which I thought was again, light bulbs sort of going off, or neurons connecting in my mind. Finding child by name, so recursively looking through all of the children and saying, okay, have we found it? And this is cool, because one of the things I could start to do down the line is let's say I put together an FPS kind of like little prototype thing, and it's got multiple levels, and I want to optimize. I can go down to the nitty gritty here, and I can really figure out, okay, is find child by name heavy? Because in Unity land, we've got this game object.find, which we say, yeah, use it on initialization perhaps, but don't use it with an update because it's heavy. Sorry, just finishing off my coffee there. I think I might have explored these or talked about these a little bit before, but getting position and world position. And this was where I said, like, the world transform. And I've forgotten where it is actually. Sorry, it's related to the parents somewhere. So again, if you've got like a child of a child and you want to get like the grandchild position, you also have to factor in the position of the parent and then go up the chain to figure out the final position. But the point, I guess, the other point is, yeah, I can start to go in and really understand like how long each of these is taking. I've not done a lot of profiling within Visual Studio before, or I could just do this manually and put in a bunch of defines of profiling, and if I have the profiler define turned on, then it can time every single one of these. Maybe I'll have to explore that a little bit more. Let's just quickly see what else I wanted to talk about. I think maybe the last thing was probably the specular part as well. So if I go to shaders, and this is the only shader that we've got in the project at the moment. So the fragment shader, sort of the specular calculation. I think it was the default one, if I remember correctly. I think it might have been actually. Yeah. So we've got a default one. Now this is where I'm a little bit unclear of what's happening. We've got a default one. I think maybe because we've not set the parsed GLTF model to use these ones, and we're just grabbing the default one. I've got to figure that out. Maybe once this course is finished, I'll be able to go in here and say, okay, I'll add more shaders, and I can define which shader, which particular model is using, or which particular material is connected to which shader. But fragment shader here anyway, so this is where we're doing the diffuse lighting calculations and then the specular lighting calculations, and then putting it all together at the end. There's a really good website that I used to kind of understand this a while back. I think it was called learnopengl.com. I've got it in some of my other videos, but a lot of this made sense, and it's one of those where I'm revisiting it like 6 months or a year later. I try to comment things fairly aggressively to understand things as I'm coming back, but specular is based on the view direction and the reflection direction. So where is the eye, or the virtual eye, or the virtual camera compared to the reflection? What is the direction of reflection? Is it a perfect 45, or are you at like a lower angle? And then based off of that view direction and the reflection direction, we get specular. And here I've sort of like made a little bit of a couple of notes of how each of these not operators, functions, built-in GLSL functions are getting applied, and what they actually do. But what we do to kind of summarize is we get the result of the diffuse plus the specular. Then we sample the texture color, which is the gun material, or the monkey Suzanne material, or the brick cube, whatever it may be, and then combine those together. So like I say, eventually I think this is if there's no default shader. I think that's what was happening. There's no default shader within, or there's no shader within the GLTF file. We're going to use the default ones here. But there may have been one within that GLTF file, but I don't know if that's been factored in with what I'm currently working on, or how this has all been put together. Again, I'm learning as I go. This is a lot of really interesting stuff. The animation component really, like I say, kind of lit a bit of a light bulb in my head of how this kind of works, and okay, when I see this in Unity now, okay, this makes a lot more sense now. It's I'm understanding the kind of the underlying tech, let's say. But I think I'll probably cut it there. I don't want this video to go on too long, and again, I can't share all of this code because this is a course on Udemy that I'm going through. The link is in the description for that course. It is an affiliate link, full disclosure. It just helps support the channel, and I'd get a small percentage if you did purchase it, but I do recommend it anyway. I'm going to keep going with these videos because they're helping me. As I said, I'm learning as I'm going through, so I'm typing and following along with the code through this course, but as I'm talking through these videos, it's making more sense. I'm like, okay, now I understand, and I'm sort of watching the videos ahead, then typing, then also doing these. I'm finding that useful. So any question, guys, pop them in the comments. I'll catch you later. Bye.